Okay, for these problems, we will not, for these problems, we cannot solve for a variable when it is in the denominator. So this x right here, this is not 6x. We can't move it to the other side. We can't combine it with anything else. So whenever we have a variable in the denominator, the strategy that we're going to use for these problems is we're going to try to get common denominators for everything in the whole equation. So right now, 6 over x is the only one that has a denominator, but I can put a denominator with the 5 by just putting it over 1. And I can also make this x over 1. So my denominator here, I've got an x and a 1 and a 1. So I'm going to use x as my denominator. So to put an x in the denominator here, I would have to multiply the bottom by x. If I multiply the bottom by x, I must also multiply the numerator by x. Same thing over here. I need an x in the denominator, and that means I need an x in the numerator as well. So when I do that, I'm going to get 6 over x minus 5x over x equals x squared over x. Now in this problem, I'm going to kind of do it the long way because I want you to understand why we can do this. So these have common denominators right here. It's like, you know, it's like having 1 half and 3 halves. So I can subtract the numerators, 6 minus 5x, and put it all over that common denominator. All right, so I can put those together since they have the same common denominator. And that'll equal x squared over x. Okay, so when I have this, the only possible way that these can be the same is if the numerators are the same, right? Because the denominators are already the same. No matter what x is, they're already the same. So really, at this point, I can disregard the denominators. The other way you can think of it is like if we want to get rid of that x in the denominator, I would multiply both sides by x, which is like x over 1, which would cancel those x's out in the bottom. So those denominators, we're going to drop them at this point, and we'll get 6 minus 5x equals x squared. Okay, so at this point, we are down to a quadratic. So, Brandon, what's the first thing we do if we're going to solve a quadratic? Everything to one side. So, I'm going to move everything over here with my x squared. So, I'll have x squared plus 5x minus 6. And I'm going to factor that. Brandon, how does that factor? Not 3 and 2 on this one. Okay. All right. Which one's positive? Which one's negative? Negative 1, positive 6. Good. Negative 1, positive 6. That one's a tricky one because 2 and 3 also add up to 5, but they won't give you the negative 6 right here. You got to have different signs. So be careful with those. Alright, so that means that you get the answers x equals 1 and x equals negative 6. Now, these problems, you do kind of have to check your answers. You don't have to check your answers to the extent that you did with the square root problems. What you have to check for on these problems is we cannot have an x in the denominator of a fraction. Right? So basically, I just need to go back to that original equation, which was 6 over x minus 5 equals x, and make sure that if I plug these numbers in, that it's not giving me a 0 in the denominator of a fraction. So if I plug in 1 right here, then I'll have 6 over 1. That's fine. If I plug in negative 6, right here I'll have 6 over negative 6. That's fine as well. So both of these are my answers. What's the only number that you could not have for this problem? What's the only number that you'd have to throw out? 0. If you had the answer of 0, you would need to mark that out because that would give you a 0 in the denominator. So when you finish these problems, you do need to check them, but you just have to check to make sure it does not give you a 0 in the denominator. Although you can check them completely to make sure you got the right numbers also. Alright, questions so far? Okay, here's your next one. Example 2 is going to be a little bit more difficult because when you look at your denominators, you've got several different denominators here. Last time we could just pretty clearly use x as our denominator. Here we've got 3x, 6x squared, 8x, and 3x squared. So, so the first thing you want to do is think about the numbers that you have and think about what is the least common denominator. So you might be able to come up with that off the top of your head. That's good. I'm going to do it the long way again just to sort of clarify in case you're having trouble. So like if we're looking for least common denominator, first of all, you can always get a common denominator by multiplying all three of the numbers together, 3 times 6 times 8. But that's going to give you a bigger number than you want to use. The other way you can do this, if you think, well, you've got 3, 6, 9, 12, 15, 18. If you're just doing all the multiples of 3, all right, all your multiplication tables, 21, 24, 27, 30, that probably is far enough. For 6, you would do 6, 12, 18, 24, 30, and we already got to the highest we had there, so maybe that'll work. For 8, we'd have 8, 16, 24, 32, and so on. So what you're looking for is the first number that is a multiple of all three of them, right? What's the first number that's a multiple of all three? 24 is a multiple of all three of them, right? So that is your least common denominator. So sometimes it's easier to think of than others. So you need 24 to be your least common denominator. Also, some of these have just an x and some of them have an x squared. That part has to match as well. So our least common denominator here is going to be 24x squared. So you have to use the highest exponent of whatever variable you have there. So that means I need to multiply each one of these fractions by something so that I will get 24x squared in the denominator. So for the first one, I would have to multiply by 8 to get to 24. And I've only got an x, so I also have to multiply by an x. So that means I'm multiplying by 8 and x in the numerator as well. For the second one, I would have to multiply 6 by 4 times 6, and I already have an x squared, so I don't have to multiply by a variable at all. For the third fraction, I need to multiply by 3. And I also need to multiply by an x because I only have a single x there. So I have multiply by 3 and by x in the top. And for the last one, I'm going to have to multiply by 8, but I do not have to multiply by an x. So whenever I do this, it's going to give me, I see 56x over 24x squared plus 16 over 24x squared equals 15x over 24x squared. squared minus 16, thank you, over 24x squared. And so if I wanted to, I could do like I did on the last problem. I could write it where both sides are all over 24x squared because they match. And I could multiply by 24x squared to get rid of it. But essentially, once you get all of your denominators to match, it's okay with me if you don't show those steps. So I'm just going to mark out my denominators. All right. So that gives me 56x plus 16 equals 15x minus 16. Okay, is this a quadratic? It is not a quadratic. I'm just solving this like a regular equation, like we're in Math 1. All right, so I'm going to subtract the 15x over here. So that will give me 41x plus 16 equals negative 16. I'm going to subtract my 16. So 41x equals negative 32. And then I'll divide by that 41. And so it's an ugly answer, but your answer is x equals negative 32 over 41. Is that answer okay? Will it give you a 0 in the denominator of any of your original equation? Okay, it will be fine because what's the only number that could give you a 0 in the denominator for this one? 0 is the only thing. 0 is the only number. It's not always, but it is on these first two. So this is your answer. Okay, questions? Okay, here's your next one. So here we have x plus 3 over x minus 4 equals x minus 5 over x plus 4. So this one is going to be different than the first two examples we did because we don't have a number multiplied by our x. We have a number added or subtracted. So if we think about this, I'm just going over to the side, think about something for a second. You don't necessarily have to write this down. On the last few problems, if I had a fraction, let's say if I just had 3/4, all right? On the last few problems, I've been multiplying the top and bottom by something. I've been like multiplying the top and bottom by 2. So that is 6 over 8. Does 3/4 still equal 6 over 8? Right? Because if I have a pizza and I split it into 4 pieces and I color in 3 of them, it's the same as if I have the same size pizza, I split it into 8 pieces, and I color in 6 of them. Right? They're equal, equivalent fractions. So what you've got to know here, is it okay for me to do this? 3 over 4 and do plus 2 and plus 2. So that would be 5 over 6. Is that okay? That's not okay. Because over here you got your pizza, 3 out of 4 pieces. Over here, you've got your same size pizza. We're going to split it into 6 pieces. I know those aren't perfectly even. And color in 1, 2, 3, 4, 5 of them. Are those equal to each other? They are not. Even if I had drawn it, better, you could see it better. But even here, you can tell those are not the same. So you can multiply a fraction on top and bottom, and it will give you the same value. But you cannot add and subtract. So like you might be tempted here to do like, I could do plus 8 right here and plus 8 right here. Don't write this down because it's wrong. So that'd give you x plus 11 over x plus 4, and then your denominators match. But you cannot do that. You cannot add and subtract to the bottom of a fraction. You can only multiply. So that changes the way we're going to have to do this problem. So let's think, they're not written, but it's like you've got parentheses around all of this. Okay? You could cross multiply, but I'm going to show you a different way just so the way I show you works on every problem and not just a certain type of problem. You'll see essentially it's going to be cross multiplying. So my least common denominator here is going to be the two things that I have on the denominator. So I'll have x minus 4 times x plus 4. So for that first fraction, I have an x minus 4 in the denominator. I do not have an x plus 4, so I would have to add an x plus 4 in the denominator, which means I would also have to add an x plus 4 in the numerator. And over here on the right-hand side, I have an x plus 4 in the denominator here. I need an x minus 4 for my least common denominator, so I'd have x minus 4 on top and bottom. Yes? Sometimes we'll see it repeated. So, like when we get to ones where we have more than one fraction for these, sometimes we'll see like maybe 2 of them have x minus 4s and this third one has an x plus 4. So sometimes we'll see it repeated. We'll see it in another problem though. So no, not always. But at this point, I've got the denominator here is x plus 4, x minus 4. The denominator here is x plus 4, x minus 4. All right. So since I have the same denominator, is it okay with you guys if I don't write a separate step, if I just go ahead and cross my denominators out since they match? So that leaves me with, make sure, and the kids that mess this up, I do this in math too. I also do ones that are a little bit more difficult in math, in pre-calculus. And some kids refuse to write parentheses, and those kids always do bad in this section. Okay? You got to put your parentheses. So you've got x plus 4 times x plus 3. And you've got x minus 5 times x minus 4. You'll notice if you had cross multiplied, you do x plus 3 times x plus 4, that's this side, and you do x minus 4 times x minus 5, that's this side here. So you can cross multiply here if you want. It's just not going to work on all the problems. So it would only work when you have these two equal to each other. So that's why I'm showing you the other way. Okay, so now what in the world are we going to do? Cry. Adam suggests that we cry. So, okay, we could distribute to make them quadratics on each side. So after we get done crying, we'll distribute. Okay? So x squared plus 3x plus 4x plus 12 on that left-hand side. And then over here, we'll have x squared minus 4x minus 5x plus 20. So if over here I've got x squared plus 7x plus 12, and it's fine if you skip straight to that if you can do that in your head. X squared minus 9x plus 20. Alright, now we got a quadratic. Normally we would move everything to one side, but it looks like we have a quadratic here, but we don't really. Why not? Okay, what's going to happen when I start moving everything to one side? When I subtract that x squared, what happens to it? It's going to cancel on both sides. So this one's not really a quadratic because the x's cancel. So you could try solving it like a quadratic, but the x squareds are going to cancel. So that leaves us with 7x plus 12 equals negative 9x plus 20. And then you want to move your x's first. I would add that 9x to try to avoid some negatives. So we get 16x plus 12 equals 20. I would subtract 12. So 16x equals 8. And I would divide by 16. What is 8 divided by 16? 1/2. There. And then you always want to go back up to the original equation and see if it would give you a 0 in the denominator. So in this case, if I put a 1/2 here in each one of these places, does it give me a 0 in the denominator? It does not. In this case, what numbers would? What numbers can we not have? Would it be okay to have 0 on this one? 0 is okay because 0 minus 4 would be negative 4 and 0 plus 4 would be positive 4. So 0 would be okay on this one. What numbers would give you a 0 in the denominator, Katie? 4 would be one of them and negative 4. So if you got 4 or negative 4 for this problem, then you would cross that out because it would be an excluded value. You could not use it. So they'll give you that 0 in the denominator. Those extraneous solutions are a lot less common on these problems than they are on the radical equations. On the square root problems, you really, really, really have to check every single one, or you're probably going to miss a lot of problems. On these problems, you could probably forget to check and get most of them right. There's going to be 1 or 2 here or there that are extraneous, but it's not as often. Still check them. Okay, questions? All right, here's our next one. I love these problems. You can impress somebody with this sort of math. It starts to get impressive looking because this looks scary, right? It's not that hard. It's not that hard. In fact, I think this one is easier than the last problem, okay? You just need to be taught how to do it because you don't know how to do it yet. So let's talk about the least common denominator, because if you can get the least common denominator, then that's the most difficult part for a lot of students. So now a common denominator. You can always get a common denominator by doing, don't write this down because we're going to do it an easier way, but I could do x minus 5 times x squared minus 25 times x plus 5. Right? That could be a common denominator. And if I do that, that means I'd have to multiply this equation by like x squared minus 25 and x plus 5 because it's on top and bottom. And then I'd have to multiply this one by x minus 5 and x plus 5. And then I'd have to multiply this one by x squared minus 25 and x minus 5. And then you've got things like to the third power. We don't know how to solve things to the third power. You're going to stall out here. You're not going to be able to finish this one. Based on what you know, you can't finish the problem if you do it this way. Okay? But I've got good news for you. Okay? There's a way to make this much easier. Okay? Because I've got this x squared minus 25. I feel like that should factor. How could I factor x squared minus 25? X minus 5, x plus 5. It's a difference of squares. So if I rewrite this like this, 3 over x minus 5 minus 20 over, let's factor this, x minus 5, x plus 5 equals 2 over x plus 5. That is going to change our least common denominator. Because when we have a least common denominator, and you can write this stuff down now because I'm doing it right. or the easier way, I guess I should say. You can do it the other way, but it would be painful, and you don't know how to do several things you have to do. So if I have this, the least common denominator, we can just take all of the denominators and multiply them together, but if you already have used that part of the denominator, you don't have to use it again. So for example here, like if I have x minus 5 times x plus 5, which is this denominator right here, I don't have to add another x minus 5 or another x plus 5 because those are already here. Okay? So the least common denominator here is just x minus 5 times x plus 5. So that means if I'm using x minus 5 times x plus 5 as my denominator, then if I look at this first fraction here, Maggie, what's missing? What do I need to get that least common denominator? The x plus 5. So I would multiply the denominator by x plus 5 here and x plus 5 here. Okay? So that gives me the least common denominator that I need. Adam, the second one, what do I need to add, or do I need to add anything? Don't need to add anything because this already has the least common denominator, right? And then let's put some parentheses around this. Aaliyah, for the last one, what do I need to add in the denominator there? An x minus 5. So I'll have to multiply by x minus 5 in the top and bottom. So you're just going through each fraction and trying to see what you need to add to get your, or multiply to get your least common denominator. And once you get a least common denominator, or get all of those denominators the same, I could do a bunch of work to like show it why it works, but it's okay with me if you don't. I can just mark out the denominators because they're all the same. So that leaves me with 3 times x plus 5 minus 20 equals 2 times x minus 5. Okay. Let's see. Roxana, what do you think we should do next? Okay. Let's distribute that 3, and while we're at it, we'll go ahead and distribute that 2 over there. So 3x plus 15 minus 20 equals 2x minus 10. Is this going to be a quadratic? This one's not a quadratic. It's just a regular old equation. So if we combine that 15 and the negative 20, we get 3x minus 5 equals 2x minus 10. Okay, let's see. Jalen, what would we do next? Good. So that gives me x minus 5 equals negative 10. And then last step, we'll add that 5. So I get x equals negative 5. But what do we have to do? You got to check it. Is negative 5 going to give you a 0 in any of those denominators? It will. Because right here, either here or here, it's going to give you a 0 in the denominator, right? Because negative 5 plus 5 gives you 0. So although we got an answer, it's going to give you a 0 in the denominator. So this problem is going to be no solution. I always find that disappointing. And what that means is there's no number in the whole world that you could plug into that equation where the two sides would equal. This doesn't work. Okay. Questions? Alright, try this next one. Alright, write this one down. This one, I think is possibly easier than, no harder than the last, I'll say that. No harder than the last. I'll say it's no harder than the last. 3. Alright, guys. You guys are freaking out because these are fractions. They aren't that bad. You can do it. I've taught it before. Last year's class could do it. You can do it. You have a bad case. They didn't. They did not have an extra year. It was math. It was just a math 2 class, honors math 2 class, just like you guys. So last. They were not any smarter than you. You can do this. So, you guys have a terrible case of the fraction phobia. It's not that bad. The fractions, it's not even that much. It's not. It's not. If you guys tell yourself that this is so hard and no, I can't do it, guess what? You can't. Okay? Instead, you need to be thinking, oh, look, this looks really hard, but I think I'm figuring out how to do it. Or, Miss Hyatt, I didn't understand this part. Could you show me how to do that again? Okay? Because I promise you guys can do this. It is not that bad. You can do it. But if you freak out, you can't do it. Okay. So, take a deep breath, calm, look at this problem. Alright, so ideas of what we should try to do first. Kayla, let's factor the bottom. Because if we try to use that as our least common denominator, it's going to be terrible, right? It would be worth having a panic attack over if we're trying to do it without factoring those denominators first. So, just leave the numerator alone. The bottom of this first one is going to factor into x plus 2 times x plus 3. Okay? We okay there? The second one, x plus 2x minus 1. Okay, and the last one, x plus 3, x minus 1. Okay, have we done anything that you don't know how to do yet that you got questions on? Okay, we're okay? Alright, so at this point, we're looking for our least common denominator. Okay? So we're going to take a deep breath. Least common denominator. Just start with your first denominator. You know you got to have an x plus 2 and an x plus 3. Okay? And then so when you look at the second denominator, you got x plus 2, but that's already there, so you don't have to write it again. And you got an x minus 1. So we need to add that x minus 1 in. And then when we look at the third denominator, we've got an x plus 3, but that's already there. And an x minus 1, but that's already there. So we don't have to add anything else. These three right here are sufficient. You can have 3. But it's not going to be as scary as it looks, because if you look at the first fraction, you already have the x plus 2, you already have the x plus 3. What's the only one that you need? X minus 1. So we're going to multiply the top and the bottom by x minus 1. Okay? If we look at the second fraction, Colton, we already have an x plus 2 and an x minus 1. What do we need? X plus 3. So we're going to multiply in the top and the bottom by x plus 3. And Aaron, in the last one, we already have x plus 3 and an x minus 1. Which other one do we need? X plus 2. So we're going to put the x plus 2 in the top and the bottom. And now they're not all in the same order, but they all have the same denominator. And the order doesn't matter because you're just multiplying. So since you have common denominators, we can just mark that out. And so we just keep our numerators. We've got 3x times x minus 1 plus 2 times x plus 3 equals 5x times x plus 2. Alright, I'm going to stop again. Is everybody okay? Do we need to medicate anyone? Or are we going to make it? Okay. Alright, so. Alright, anybody have an idea where to go from here? Distribute. Okay, so we can distribute. That's not too bad. We know how to distribute, right? So we get 3x squared minus 3x when we distribute that 3x. Okay, here we'll get plus 2x plus 6. And over here, we'll get 5x squared plus 10x. Okay? Alright, is this one a quadratic, or are we going to solve like a normal equation? This one's a quadratic because you've got x squareds and they're not going to cancel out. So before I start moving stuff, I probably would do this. 3x squared minus x plus 6 equals 5x squared plus 10x. Combine that negative 3x and that positive 2x there. You don't have to do that step if you want. You could do it as you move it. Alright, and then with a quadratic, we move everything to one side. I would suggest moving everything over here to the right-hand side so that your x squared is still positive. So we could subtract our 3x squared. We could add our x and subtract our 6. So we'll have 0 equals 2x squared plus 11x minus 6. Okay, this one's a little harder to factor. If you get one that you can't factor, you could do quadratic formula, but you're not going to have a calculator, so the numbers will get pretty big. It's better to factor. So these are harder to factor when you have a number in front of your x squared, but we can do it. We'll have a 2x and an x. So we need to use either 2 and 3 or 6 and 1. Anybody seen the one that's going to work? 6 and 1. Yeah, which one comes first? The negative 1 right here, positive 6. If you need to check to make sure you get a negative 1x and a positive 12x, that'll give you the positive 11x there. So we've got that factored, right? Then we set each one equal to 0. This one's easy. It's x equals negative 6. Over here, you got a tiny equation to solve. It's not going to be positive 1. It's going to be 2x equals positive 1, and then you divide by 2. So x equals 1/2. So you get positive 1/2 and negative 6. Okay? And if you look back at the original equation way back up here, actually you might want to look at the factored version. It's easier to look at the factored version here. 1/2 and negative 6, could you plug that into the bottom? Is it going to give you zeros? It's not going to give you zeros. Negative 2 would give you a 0, negative 3 would give you a 0, and positive 1 would give you a 0. But that's none of those, so those are your answers. Okay? Alright, questions? I'm going to go back to the full screen. That's some impressive work right there, isn't it? I mean, you guys went all the way through that. That looks scary, doesn't it? You can go home tonight, do your homework, and show your mama, and your mama's going to say, oh, my baby's so smart. Look at this hard math that they're doing. You really impress them. Okay? Okay, you can do it. All right, let's do this one. Got a couple more. 2 more. Yep. We still got 35 minutes. Well, if y'all go ahead and write this problem down, we'll get through it pretty quick. Okay. These next 2 problems are not really any more difficult than the ones we've done so far, but when I give these next two problems, I can almost guarantee half the class is going to miss them. Okay? I can almost guarantee half the, in this class or in pre-calculus, whenever I'm teaching that class as well, I can almost guarantee half the class is going to miss a problem like this. And let me show you what the problem is. The problem is this minus sign right here. Because that minus sign right there is going to have to be distributed. And most students forget to distribute the negative with the number, right? And so they'll do everything right. You can tell they know what they're doing, but they forget to distribute that negative with the number, and then they don't get the problem right. So if you see a minus sign in your problem, beware. Okay, you got to be really careful if you have that minus sign in your problem. As far as the setup and everything else you do, it's all the same, but you just have to remember to distribute it. Okay? So for this one, one other thing that a lot of students miss, that 7 right there, it doesn't have a denominator, so we've got to give it a denominator. Okay? So our least common denominator here is going to be, we've got an x minus 2. And the 1 we don't really have to write, because if you multiply anything by 1, it's just itself, right? And then the x plus 2. Okay. So any questions on getting that least common denominator? So once you get the least common denominator, you're just looking at each fraction and deciding what it needs. So, Jaden, that first one, 5 over x minus 2, what does it need? It needs an x plus 2 in top and bottom. Okay? David, the next fraction, the 7 over 1, what does it need? Okay? What does it need in the denominator? Right now we've just got that 1 there. What does that fraction need to be multiplied by to get a least common denominator of x minus 2 times x plus 2? It's got nothing right now, right? So it needs both x minus 2 and x plus 2. So x plus 2 and x minus 2. So x plus 2 and x minus 2. And Hugh, what about the last one? What does it need? X minus 2. Okay, now our denominators are all the same, so we can get rid of those. Be really careful right here. I do not suggest distributing first. I would write this all down. 5 times x plus 2. A lot of kids like to sort of skip ahead and distribute as they're doing that, and on some problems it's fine, but on one like this, especially when you have a minus, I would not suggest it. So you got 7 times x plus 2, x minus 2, minus 10 times x minus 2. If you don't write that, if you just distribute the 10, a lot of times you forget the negative goes with it. Now, another thing that might be confusing to you is how to deal with this right here. You do not distribute the 7 to both of these, okay? You could distribute the 7 just to the first one, but what I usually do is I just multiply these two together first. What do you get when you multiply x plus 2 times x minus 2? X squared minus 4, because the middle terms are going to cancel out there. That's a difference of squares. So I'm going to distribute my 5. So 5x plus 10 equals, I'm going to hold on to this 7, and I'm going to multiply x plus 2 times x minus 2, which we just said was x squared minus 4. And then I'm going to distribute the 10, but make sure you distribute that negative that gives everybody trouble with it. Okay? So you got negative 10x plus 20. And that right there is what most people are going to do wrong, and they're going to have negative 2x minus 20. And they'll miss the problem. Okay? And let's distribute our 7 here. So we got 5x plus 10 equals 7x squared minus 28 minus 10x plus 20. And let's put that negative 28 and the 20 together. So 5x plus 10 equals 7x squared minus 10x minus 8. Okay, normal equation or quadratic? Quadratic. So let's move everything to one side. So subtract 5x. Subtract 10. So I got, let's see, 0 equals 7x squared minus 15x minus 16. Did I make one that she has to use quadratic formula, or will that factor? It is 18. That'll help things a little. It'll factor. Not easily, but it will factor. So 7x and x. 18, we could use 1 and 18. We could use 2 and 9. We could use 3 and 6. Anybody found the one that works? 6 and 3 is going to work if we put a minus 6 here and a plus 3. You kind of have to guess and check on that. It's not super simple to figure out which one works. You're right, they do. They do. So let's make that plus and that one minus. Because that'll give you a positive 6x and a negative 21x, which will give you a negative 15x. If I give you one of these on calculator inactive, it will factor. I won't give you one on calculator inactive that will not factor. Tomorrow's quiz is going to be calculator inactive, so everything on there, if it's quadratic, will factor. So 7x plus 6 equals 0, and x minus 3 equals 0. So you get 7x equals negative 6, so x equals negative 6 sevenths. And over here, you'll get x equals 3. If you look back to the very beginning, is it okay to have both of those answers? Is that going to give you a 0 in the denominator? It will not. 2 and negative 2 are the only numbers that would. So, okay. Questions? All right, we got one more. One more. You should notice this one has a minus sign in it too. Be careful. Okay, so before we do anything, let's factor this one. It's going to be x plus 1, x minus 1. So our least common denominator. I know I have to have x plus 1, I have to have x minus 1, and then x plus 1, x minus 1. This one already has x minus 1. I've got this 2 right here. So that 2 is going to have to be part of my least common denominator. You can if you want, yes. Yeah. Okay, any questions so far? All right, so we're going to look at the first fraction. And Philip, what does the first fraction need?
The first one?
It needs a 2, so we're just multiplying by 2 on top and bottom. Okay? Kaysen, what's the second fraction need? Both what? It's already got an x minus 1. The second one. This one here. Yeah. Okay, you were telling me the last one. We can go ahead and do it. X plus 1 and x minus 1 and x plus 1 and x minus 1. Alright, so this one, Kaysen, what does it need? The x plus 1 and the 2. So, an x plus 1 and the 2. Okay, so, common denominators, we can drop the denominators. Now we're going to just use our numerators. 2 times 2 is 4. Right here, this is where everybody messes up. Okay, you have a minus sign there. I would go ahead and write it. 2 times 1 is 2, so 2 times x plus 1. If you don't write it like that, if you try to distribute, your signs are going to be wrong. And then over here, I've got 1, which I don't really have to write, times x plus 1 times x minus 1. And so right here, I'm going to distribute that negative 2. So 4 minus 2x minus 2. The biggest mistake is going to be that kids distribute that 2, and so they get minus 2x plus 2, which would be wrong here. So make sure that negative goes with it. And then over here on the right-hand side, you've got to FOIL that out, so you'll get x squared minus 1. That's the difference of squares there. Regular equation or a quadratic? Quadratic. So I'm going to put that 4 and that negative 2 together, so that's going to be 2 minus 2x equals x squared minus 1. So I got to move everything to one side, add 2x, subtract the 2. So I'm going to get 0 equals x squared plus 2x minus 3. And I will factor that. X plus 3, x minus 1. And so x equals negative 3 and x equals 1. Okay, are both of those okay? Good answers. If you plug in 3, you'll be fine. If you plug in 1 right here, 1 minus 1 will give you 0 in that original denominator. So 1 is out. Negative 3 is your only answer for that. It doesn't happen too often, but you always have to check for it. Okay? Questions?